Hello. In this video, I'm going to demonstrate a question that I got about how to solve the limit of a expression. Now, looking at this, we have that if we were to just simply plug in -1, we would see that essentially you would end up with -2. So you substitute that, you get -2 minus 2 squared minus 16 all divided by -1 plus 1, which we can see that basically this gives you -4 squared, which is actually 16 minus 16 divided by 0. So we end up with just 0 over 0, which is indeterminate form. So rule of thumb is that usually whenever you begin a limit of an expression or even function for that matter, is that you try to factor as best as possible or to rewrite the expression. Now, before we get there though, I'd like to basically kind of demonstrate how you can actually evaluate using table values before I do that. So, we can actually pick a value that's very close to -1 from the left side, such as like -1.001, and then maybe negative 0.999. So our goal is to actually substitute these values into this expression and then see what we get. Now, I already entered this into the calculator as a function, but I want to go ahead and just do it as the expression. So let's just do this. Okay, so the idea is that we're just going to plug this into our calculator. Now, when we do this, we just have to be sure that we use the appropriate number of parentheses as needed. -2, and then we square it, and then -16. And down over here, you have -1.001 plus 1. Okay, so we hit enter, and we get -16.004. So negative 16.004, that's the answer, or that's what it gets close to. Now, let's go ahead and just copy this and then just delete as needed. It might actually be just better to, might just be better to clear it all out, but we'll see. Yeah, it's probably just better to just clear it all out. Who knows? Okay, so +1, and let's see. So we just need to delete. Okay, so -0.999, and then we have -2. Now that's close parentheses, and it's going to be squared. So I think we can hit enter. So we get -15.96. Okay, now that sort of result would basically tell me that essentially you have that the limit as x approaches -1 from the left side of, we can call this f of x, like if we were to say that we have a function, but really we had an expression. So we have that this is going to be -16.004. Wait a second. Yeah, so actually, yeah, we should actually just say -16, because the idea is that you're actually saying what it tends towards. So yeah, we'll just say that it's -16, but then we'll say that the limit as x approaches -1 from the right side, if we were to call this f of x, we'll just say that this is -16. So all of this together, this actually tells us that the limit as x approaches -1 for our expression, of which, we're going to go ahead and just call it f of x. is negative 16. Now, that seems a little practical in the sense that, okay, yeah, the limit is just going to be negative 16 accordingly because we just picked arbitrary, well, not really arbitrary values, but close values to negative 1. But then it becomes a question as to like how close do we get, how many values do we need, etc. So um, another way that I could have done this is that I could have used the graph or the table. So like if I go to the table, and I already entered it in as a function. So like I already entered it in as a function. When I go to the table, I see that basically the function value is undefined at negative 1. Okay, but that's no surprise. Now, according to the setting, the calculator is telling me that it's negative 16 from the left, and it's telling me that it's negative 16 from the right. So therefore, the limit is negative 16. Now, one way that you could also say, for example, that you wanted to be able to see the graph, it's probably going to be best that you, let's see, let's set the window to like -5. That way we can see the whole graph, because we have that the minimum. We need to make the window just a little bit bigger. I think that's going to be good enough. So we'll just do this graph. Okay, so we can actually go ahead and use the table values similarly by going to second trace and then by inputting the values. So like you had some homework questions that it asked you to plug in values. So like let's say that you plugged in -1.0001, you just hit enter, and it tells me that let's see. It's telling me that it's -4. Let's see. Let me do that again because, okay, so that's the undefined part. Um, Let me see if I do -1.1. Oh, okay, I think it's giving me fractions. Let's say like -2. Oops. Okay, so yeah, I guess if anything, like you can always like just change the settings. I'm gonna change the settings later on today. That way it doesn't do that. So it's giving me like values as their rational expressions. And that's because of the fact that it's a rational expression in the first place. So the calculator is giving me these rational expressions. But we can actually convert that, later on. But the point is that you could, plug in values into the calculator as a function and then see where that goes towards. But the idea is that you want to be able to do this any other way. So let's say that we were to use another method. So the other method that we could probably use is by either factoring or by expanding. So take a look at your expression 2x minus 2 squared, 2x minus 2 squared minus 16. And all of this is divided by x plus 1. Now, in my mind, I'm going to tell myself that I could probably just FOIL this out, and I'll get 4x squared minus 8x minus 4. Actually, it's plus 4 minus 16, all divided by x plus 1. But the thing, though, is that this does reduce even further as 4x squared minus 8x minus 12, all divided by x plus 1. Now, if you factor this, you can factor this as 4 times x minus 3 multiplied by x plus 1, which this gives us divided by x plus 1. But then we notice that that cancels out the x plus 1 factor. So it reduces the expression down to 4 times x minus 3. So that's 4x, not 4x, but 4 times x minus 3. Okay, now in this case, the limit of the function is actually going to be, when you write this, when you write the limit as x approaches -1 of 4 times x minus 3, you end up with 4 times -4, which is equal to -16. So the limit is actually -16. So that was by expansion, and I kind of skipped a step where I didn't take out the 4 first because I saw it as a greatest common factor. Um, and then I just factored it even further. But let me just point out that the expression, when you first look at it, so when you first plugged in -1 and you figured out that it was indeterminate form, immediately you should have told yourself that you have to rewrite the expression. Even when you have complex fractions, you know that you need to reduce it and rewrite it and simplify it, and then evaluate it again. So I'm noticing that when I looked at it, that this is a perfect, this is a difference of squares. So we have that a squared minus b squared is equal to a plus b multiplied by a minus b. So what that did is it told me that I could just factor immediately instead of expanding. I'd rather not do extra work, so in that case I just factor. So 2x minus 2, now 16 is actually 4 squared. So that's going to be plus 4 multiplied by 2x minus 2 minus 4, all divided by x plus 1. But basically you end up with 2x minus 2 times x plus 4. Actually, it's plus 2 because, yeah, 4 minus 2 is 2. So we have 2x plus 2. And then you have 2x minus 6. So you have 2x minus 6 divided by x plus 1. Now, when you factor again, because these are not completely factored, you have 2 times x plus 1, and then you have 2 times x minus 3. Now, basically, you end up with 4 times x plus 1 and x minus 3, which is the exact same thing that I showed up over here. So we end up with that the expression becomes 4 multiplied by x plus 1 multiplied by x minus 3, all divided by x plus 1. But what ends up happening is that the factor of x plus 1 actually will cancel out, and then basically you end up with that it's simplified to 4 multiplied by x minus 3. So similarly, you have that, you're going to take the limit, and that the limit comes out to -16, same thing. Yeah, -1, 4 times x minus 3. And then you have that that's a linear function. So basically at that point, it's just a matter of just substituting, which you get -16 still. So more or less, it's going to be like preference whether you want to use factor methods of foiling, or you use the table values, and then you just determine from there. The other way that you could probably go about solving that is actually by using the graphing calculator. Like if you look at the graph itself, um, I went ahead and made a video, not a video, but a graph of the function using Desmos. So I went to Desmos and I entered in this function. Um, so I used the expression and I wrote it as a function. And I made a table using negative 1.1 and then so on. So you see that on the table, it has that it's undefined. Now, if I click on the function right at -1, I see that it's undefined. So in that case, we have that it's kind of like, yeah, okay, it's indeterminate. So it's uncertain, like uh, what's going on at -1. But if I use my table values, I can actually see, what's happening. So like, we have negative 15.996. We get a little closer and we get -16, but that's because the system is rounding it. Similarly, from the left side, you have that it's also rounding it to -16. Then over here, it's as you get further away, it's giving you -16.004. So in any case, you come up with the same conclusion that the limit of the function, or the expression for that matter, is -16. So there's many different options that you have in terms of like figuring out like, what is the limit of the function or expression. So it's more or less like, do you prefer to use factoring methods, or do you prefer to use the graphing calculator, or do you prefer to use table methods? But as it relates to, when it comes to like your exam, it's actually going to be dependent on, how the question says to solve it, like whether it's by using the graphing calculator for the table values or solving it algebraically. Um, so the idea is that you kind of want to be familiar with those different methods that are outlined in, I think it's like 2.2 or so, the techniques of finding limits. Now, for now, you won't be able to use like advanced techniques, which uses the numerator and the denominator. Those that have already taken Cal 1 or have taken Cal in high school, say, you might already have a technique of how do you find the limit using a more advanced technique, which will be discussed like a little later in the course in section 4.7. So if you're already familiar with that technique, unfortunately, you won't be able to use it just yet. But once we do cover it, then you may use that technique, and you may apply it to some of the different forms of indeterminants that you used or saw in 2.2 or even 2.3 for the final exam.